I'm one of the Dans. I was here last year talking about a program called Test Clutch, which I was in the process of developing. One moment here. Okay. And I'm happy to say that the initial product is done, and it's been running for, well, a good chunk of the year anyways. So what I'm going to talk about here is not Test Clutch per se, but really what we can use it for. So it was built again specifically for curl, but it's designed to be used for practically any project that has tests. So it tracks and analyzes the automatic regression test results. So if you ever run tests or make tests, then you can see that curl runs, up to 2,000 tests now, not even including the pi test, which is another few hundred. But when we're talking about 200 CI jobs and tests running on every single commit, you're talking a lot of tests, like in the order of millions of tests in a year. What it does is when the test is run on this the CI service, it downloads it and stores it into a database. It will also look at PRs that people push to GitHub, and it looks at the tests that are run for those PRs. And if it notices failures, then it'll tell you something useful about those failures. Specifically, if the test is flaky, and therefore maybe the failure is not necessarily due to your own changes. It also tells you how many times that test failed in the different CIs. So, it supports the curl test format, which is really a custom one. It supports the pi test format as well, so it can grab the results of the pi tests. It also supports just generic Python unit test output as well, and also autoconf tests. So you can actually use it immediately for other projects fairly easily. So again, I'm not going to be talking too much more about what Test Clutch does, but rather what some of the data is that it collects and how we can potentially use that to improve curl. And hopefully spur your imagination on what we can use this data for curl and for other things. And it's also open source as well, so you can download and use it today. So the most straightforward thing that Test Clutch does is just generate some static reports. So there's a number that it creates automatically. You can go to testclutch.curl.se and you can look at them right now. They're updated right now 4 times a day, so they're generally pretty fresh. This is the first test that you get. And I don't expect you to read all the details, but basically green is good, red is bad. So the green, if you look at each row is a particular CI job that generates test results. Each column is a particular commit. So the intersection shows you the color, which is green if all the tests are successful, red if at least one failed, yellow is in case the test did not run to completion, if it hung or something and the CI job killed it, and then there's a few oranges which are unknown. So the number you see there is the actual number of tests that have run to success, or in the case of red, then it's the number of tests that have failed. And if you hover over the cell, you can see a little bit more information about the test as well. So perma-fail, you can see on the left there for the red line. This is a particular CI service, or not a CI service, but rather an auto build that someone is running. And there's some systematic issue with running a test on Solaris. It crashes, but since we don't have control over this box, there's not a lot we can do without access to this particular machine. I tried running on a different Solaris machine, couldn't reproduce it. So here's another static report. This shows you all the tests that have failed in the last month, and it's sorted by the number of times that it's failed. So you can see test 580 is really having issues somewhere. It gives you links to the log output so that you can actually go and take a look at what is failing and how it's failing. So if you're running this test and it failed and you're thinking, is that something to do with my service or not? And normally if the test is known to be flaky, and by the flakiness is determined by a number of test failures, a number of test successes all within a certain time frame. Test clutch will tell you, but if it doesn't reach that criteria of flakiness, but you can see here whether or not it has actually failed in the past or not. And you can also compare your logs to these logs and see where the differences are, if maybe it's the same root cause or not. Here's a matrix of the various job features. On the left, once again, is the row is the CI job that's being configured, and the column in this case is the particular feature or the particular configuration for that job. So the first one's, I wonder if you can see my cursor, if I can move it over there. Here we go. So this is the architecture, for example. There's some ARM ones here. There's 386, there's x86 64. So you can see that this particular job running on Circle, can't quite read it from here, but it's running x86. This particular one is ARM. It's, didn't want to do that. It's using the automake build system as opposed to CMake. It's using GCC, and there's plenty more configurations there, especially things like the features and the protocols that are enabled in curl. So I know Victor was using this particular table as he's rearranging jobs to make sure that by consolidating jobs to reduce the number, that we're not missing out on specific features, that we're actually getting through the tests that are run for particular features. Because if the feature doesn't exist, the test doesn't run for the most part. So you can use this to ask questions like, is there a Clang job that's running with Wolf SSL? Are we testing that? Are there any jobs that have RTSP enabled? HTTP, sure. RTSP, maybe, maybe not. Go to the table, find out. And the NetBSD jobs, yes, I'm there. What architecture are they running at? You can see very easily from that table. Here's a metadata table. Each time the test clutch grabs the test results, it also extracts as much metadata as it can for each test. That includes things like the architecture that the test is running under. There's, if the CI system provides it, the number of cores that are available to the job. There's the operating system that the runner is actually running at. There's all kinds of things like that, build parameters, machine information, the various curl options that are enabled for that build, the GitHub commit ID that's being tested, the time the job starts, etc. There's 74 different pieces of data that we're collecting at the time, but not every job actually has all that data. Sometimes we can get it, sometimes we can't, and as much as we can, we provide. So here's another report. This is just basic statistics on the job. So the report on the website gives you the last 3 months worth of data. This particular one I ran just for the last year, so we can see for comparison a little bit more data. I've got some highlights here. So over the last year, we've run 350 million tests. There's over 400 different test configurations that have contributed to these results. The thing is, even a minor change in a CI configuration causes it to be treated as a brand new configuration. So we're not running 400 at once. I forget what the number is right now. It's something like around 200. Not all of those are actually generating test results. And that's an important thing to consider about Test Clutch. It only looks at jobs that actually create test results. We have a few jobs that are compile only, and then they just simply won't show up in Test Clutch at all. So down, where is it? Where's my cursor here? Well, you can find it later. 0.0024% of tests run in the last year have failed. So that's not too bad, right? And this is a number that Daniel was alluding to earlier. So for every single day, we're running tests for 8.4 days. That's on average for the whole year. So if we wanted to configure one server just to sit there continuously running tests all the time, that's single-threaded, mind you, we'd actually need more than 8 servers just running continuously just to get through all the tests that we're running. So on average, a test run takes 7 minutes. The most number of tests that are actually run in a single job is 1,749. And I think we have over 2,000 tests now, so that means there's about 250 tests that are not being run in that job. And that's simply because some configurations are mutually exclusive. So some tests only run if you have GNU TLS configured in your job. Others only if you have OpenSSL. So there's no way you can actually run all of them at once. The average number of tests is 1,480. And 71% of jobs are using Automake, and the remainder are using CMake. And nearly half of our jobs, 47%, are not being run on Linux. So that was actually higher than I realized. But we're getting a pretty good wide perspective of a system that we're testing on the CI services, which is good. So the log data, the test clutch itself runs as a series of batch jobs, and I'm collecting all the logs, and I'm doing a little bit of processing of them. So that logs anything that might go wrong with the job. I'm downloading the manual right now, and I'm just producing this graph on demand, which is every once in a while, just to make sure things are still working. So this is the little graph that I get, and you can see the purple lines are on the left is the duration that each job takes. So the purple lines are the main job. I call it the daily job. This is actually run 4 times a day these days, but it takes anywhere from about 1 to 2 hours to run, just a little bit more than an hour by default. The PR analysis jobs, the PR comment jobs. The analysis jobs is what runs to look at PRs and whether or not any jobs have failed. Those are currently run basically every half hour, with some exceptions, just to avoid jobs stopping on each other. And the number of comments that are generated by that job are the blue lines there. So mostly when there's a comment generated, there's just a comment on a single PR. Sometimes if people are generating a lot of PRs at once, then we'll get 2 comments in a half-hour job. That's basically that. So TestClutch stores all its data in a database. It's the central store of everything that it collects. All the reports generated from that database, and it's a source of the flakiness data that the PR jobs looks at. There's a feature to export all the data in open metrics format, which I've just started experimenting with it fairly recently, and the rest of the presentation shows you a few of the graphs that you can generate from that. So within the database we have the metadata of the job, of course. It also stores each test number that is run and the result of that test and how long that test took to execute, and any error text that shows up. Like sometimes there's a little short reason for the test failure, and that's logged as well. So open metrics is an open format that was born in the Prometheus monitoring project. So they attempted to create an IDTF standard based on this, but that was abandoned fairly recently, actually. There's another thing called open telemetry, which works in some of the same space. Open metrics is simpler and faster, and it's actually being used today, unlike open telemetry from what I understand. So a lot of software still calls it the Prometheus format. And it's a simple text-based format. And you can look at this little example here. There's a bit of metadata about the metric. So this one is a test clutch test duration seconds, and the gauge means that it's a value that is a current snapshot of what the value is at the current time. It can go up or down. There's other types like counters, which only go up. There's a histogram, which can store a distribution of discrete events. And there's an info type that shows information about the particular configuration that doesn't change for the lifetime. So you can see here the unit for this particular metric is seconds, and here's a description of what it is. So the metric itself, where did my cursor go? There it is. So this is the current value. So at this point, this metric was created. This particular test was running for 2,650 seconds, and this is the time in Unix timestamp, the epoch format at which this data came from. So this is a basic example of open metrics. You can see a real-life example. So you can see it's basically the same line, test collection, test duration, seconds, same value, same time, but all here in the middle is all kinds of values that you can drill down for when you're looking at specific metrics. So, for example, you can look at the we've got the compiler in over here. So you can decide, okay, I only want to look at metrics that use the GNU-C compiler, or the compiler version, or anything else in here, the system OS, whatever. This is all stored and it's all available to you when you're querying the data. So here's one particular graph that was created. This is from the beginning of the year. You can see a couple of discontinuities here. So this one here I suspect has to do with the way I was populating the data. I was doing it in various stages because it's quite a slow process to import into Prometheus. And I was trying to just look at pieces, and I suspect that's what happened. A couple of the other gaps are probably weekends and holidays when no one was actually doing any commits. We do occasionally go for a day or two without actually anyone submitting anything.
Slackers.
Room for improvement. So the query, this is the PromQL, I think they call it, query. So this is what is actually used by Prometheus to choose the data that it's going to graph. So here is some of that same graph, I believe. Yes, that's the same graph, but at the bottom here, I cut it off in the screenshot, but it lists all the different lines that are on the graph, and you can just choose one or more of those, and it just will display that. So I've chosen one over here. This is, so this is graph of the total tests being run, and I'm looking at the maximum number here. So this is the most tests, the jobs with the most tests being run at any given time. So remember I was talking about 1749, that is most likely this figure right here at the end. You can see the particular job that created this data. Well, this is created when I was hovering over this particular point. So this particular job was this Mac OS, Clang, OpenSSL, libSSH, Sierra's job. So you can see this little bit of a dip over here right around March 1st. So I'm not exactly sure why it went down, but I did look at the logs, and sure enough, we dropped about a dozen jobs, or a dozen tests at this point. But a few days later, Victor was pretty bored, I guess, and created 11 new jobs, or 11 new tests, I should say. And so, boom, it goes up by 11 tests as those start being run. So most likely the other tests were stopped because some dependency changed, and the run tests could no longer find this dependency, and therefore just stopped running those tests. But again, someone interested can go and look at it specifically. But this is kind of graphic that could be useful if you want to try to figure out where and when the number of tests have dropped. You can see here there's something else that dropped. And again, if this sort of thing happens frequently or more often, it might be worthwhile creating an alert so that we're automatically notified if all of a sudden the number of tests being run drops for some reason, because it could be, like there was one time when I think one of the Windows tests, some dependency changed, and all of a sudden all the HTTPS tests, I think, just stopped running. There was like S-tunnel is gone or something. I forget the details. But that would be very obvious in a graph like this. But unless you're actually looking for this sort of thing, you wouldn't necessarily notice it, because the test harness is designed to skip any tests that it can't run, because there's no point in even trying to run those.
Yeah, that's really a weakness sometimes. The system. This flexibility. They're too flexible inside, you go, okay, let's skip this.
Yeah, and when you expect it to be run, then you want it to be run. So this is a different graph of the total number of tests that have failed. So I'm looking at failures over a 2-hour interval. And so you can see here, for the most part, we're at 0, yay! And then occasionally spikes of 1 or 2 up to 5. So on February 6th over here, there's a huge spike here. So at this point, Windows was starting to time out and fail tests. Victor goes, oh yes, I remember that. And sure enough, Victor committed this commit with the title, Mitigate Drastic Run Tests Perf Drop. And boom, all of a sudden the test started running it. So thank you once again. This April 1st spike, I couldn't figure out what the cause was. It just looked like a bunch of random failures across different OSs. So I don't know.
It was the same thing.
Same kind of thing there.
April
Variation of
the
it.
tariffs were announced.
Right there, yes. Servers were protesting.
It's about MC2 runtime that got deployed that day. So
Another
there's
runtime
One
thing.
wave and another one.
Okay. So this is a graph of tests run by test format and results. So you can decide what you want to break down these tests by just entering it over here. So here you get way more than you really need. So you can, so you can see more of a list of the different options that you have available to you. And again, Prometheus just lets you click on any of these and you can see just that data itself. So you look, for example, here's the Circle CI test that were skipped using the curl test format. So this is the curl test, not the pi tests. And this is the ARM OpenSSL C areas curl test. You can just choose one of those and show just that line. And that's what I've done over here. This is the GHA origin, so from GitHub, with the fail ignore test result, which is a test that is run, but we know it's going to be failing, so we just ignore the results. So we have a few of those, especially on Windows. And this is a particular Windows test, the MSVC multi-SSL test. So basically it's showing the number of tests that are run and deliberately being ignored. And you can see over here, there's a little bit of a gap. I'm not sure what that was all about. But up here we're up, 47 or so. And then March 22, Victor fixed and a bunch of tests in Windows and unignored them so that the results could be found again. So sure enough, we're running all of a sudden another 42 tests. So once again, thank you.
Like this.
Yeah, it's really interesting to be able to visualize it because especially when you use it, especially because you're doing a lot of this sort of stuff, you fix a bunch of things that you see and you're running more tests. And it was green before, it's green after. Haven't made any difference. But all of a sudden, you see it like this. It's made a huge difference in code coverage. So here's a PyTest graph. So this is the PyTest being run and showing the highest number that are being skipped and failed. So the same status as the last one. And so you can see there's about 220 tests that are being marked as, this is skipped or failed, I think. My notes aren't quite good enough to tell here. But March 5th, right over here, all of a sudden the figure went up by about 35 or so. So this was when Stefan had added TLS 1.3 early data tests. Mm-hmm. And most configurations just can't run this test because they don't have the infrastructure.
Yeah, it was just implemented for GNU-TLS, so all other combinations have
right.
skipped.
So everyone else is skipped, and that you can see in this particular graph. Okay, this is a test job duration graph. So this shows how long each job that is running tests takes. So you can see the highest figures here are about 4.5 kiloseconds, so you're looking at like an hour and a half almost. And the shortest one's too small to even see. So this is split by the origin, of course, and the unique job name and test format. So each CI job basically has its own line here, which isn't very useful, so you want to aggregate some of this to make a little bit more sense of it. So now in this graph, you're no longer looking at the individual jobs, but rather the average over the source of the job. So like GitHub and Cirrus and curl auto and Circle, or which is one more? Yeah, Cirrus we're no longer running. Circle we are running, right?
Mm-hmm.
Yeah, I think that's what it is. Yeah, and the curl test and PyTest are split out as well, since they're completely different test suites. So from the top to the bottom, here we're looking at average times of around 1.4 kiloseconds. So what is that, 20 minutes or so? And so the top line is curl auto, and these are the user-generated tests that people upload to the curl auto site. And we're not using that as much anymore now that we have so many CI jobs. But people still run the tests, and it still shows failures in some configurations that the users have that we just don't have, like Solaris tests, for example. So it's still useful to take a look at it sometime. So yeah, but then again, we have no control over the servers being used here, and these servers are obviously pretty slow, and I believe they're not. Oh yeah, and they aren't being run by using parallel testing feature either. So that's why they're pretty high as well. And you can see that when we break it down by the number of parallel jobs. So if you look up top to bottom, these are the curl auto tests again, and none of them are being run in parallel. And then the next line here is the GitHub jobs being run with -J6. So this is 6 in parallel, and you can see on average this is taking about, what is that, 15 minutes or so, roughly, to complete, which matches up with the graph that you were showing earlier. We're showing that 15 minutes is about the outset. The next line here is the GitHub jobs running with 8 parallel tests, and then 4, and then finally 20 is over here, just below that. And Circle running with 14 is the lowest one. So they're roughly in order, but not quite in order by a number of parallel jobs. And I suspect that has to do with the, well, there's a few things. This is looking at the jobs without looking at the number of tests being run. So some of the faster ones are probably running fewer tests. Circle, I found it just over the years seem to work more reliably, and the servers are less loaded than the GitHub servers, so they're less over-provisioned. So when you get a server, you basically, it's yours to use. So it's just much faster for that reason.
Yeah, GitHub is much more reliable in the morning, European time.
Yeah, you're noticing a
difference.
difference.
In the afternoon, it starts becoming more jittery.
Okay, that makes some sense. Yeah, Circle I found is much better over the longer term that I've been looking at it. Yeah. So here's a graph showing the maximum job duration over the old, or for the Windows jobs rather. So I'm just looking at those. So you can see there's a huge amount of variation here.
Yeah,
we have
hung jobs probably.
that. Maybe that's what it is. That would explain it actually. Yeah, because I'm not looking at the results here.
Sometimes the Windows CI jobs just don't do anything anymore in the middle of it. Mm-hmm. No one knows.
So what's interesting is these spikes over here are the MinGW64 jobs, but somewhere in March it was the Cygwin jobs that were causing problems. So I don't know if that's a coincidence or not, but it's something that's quite obvious when you look at the data. The fastest ones at the bottom here are the Cygwin jobs. So you can see here on March 25th, the average drops from about, about 400 maybe, down to under 300, I think. And on March 25th, once again, Victor committed something called Boost DL, MinGW, and Cygwin install performance. And all of a sudden, boom, 25% performance increase. So once again, your work is appreciated. Okay, so that was just some example graphs that gives you some sort of flavor of what you can do with this data now that we have it.
You notice that someone is monitoring very
I haven't seen this, so it's just...
So again, I was using Prometheus to analyze this data. There are other programs that will do it as well. I believe Grafana can do it as well. I haven't used Grafana, but I've seen some very slick, fancy-looking graphs that you can get out of it. But I'm just using Prometheus, because I'm more used to that sort of style of analysis. So Prometheus is really designed for continuously pulled metrics. So a server that's just running continuously, and you can just pull, a number of queries or a number of requests, and then do nice graphs about the rate and this sort of thing. And it just pulls, one time per minute is common. And if the server's overloaded, or if your packet gets lost, or there's a network cable got pulled for a moment, no big deal. It'll just pull the next data, and it'll just graph that for you. So one thing it does is, if there's a delay of more than 5 minutes, then it says, oh, something's wrong here, I'm just not going to show any data. So you can see some discontinuities in some of my graphs. That was with me increasing this 5 minutes to typically 6 hours or 24 hours, because these are batch jobs we're looking at. And so they only run every 6 hours at worst case. So you just see little blips if I didn't do that. So again, Prometheus will handle that. It's just that you have to deal with that yourself. So one other downside of doing that is that if there are cases when you do expect that data to be there and it's not, then expanding that window is just going to hide that data. So you have to set that intelligently. So you can average or take the average or the maximum number over a window as well, but that can do the average or the maximum over more than just one set of jobs. So you just have to keep that in mind. In most cases, that's probably fine. You want to analyze a number of different jobs, but if you deliberately want to look at comparing one job to another, then you just have to keep that in mind and write your query appropriately. Again, I used 6 hours or 24 hours for most of these queries because it just doesn't make sense otherwise. Also, if there's a label missing, then that can typically, it has the potential to cause missing data depending on your query. For example, the parallel testing graph that I showed, the number of parallel jobs will only show up if it has been set. And if it hasn't been set, the default is 0, but depending on your query, you could simply not return any data there. And so you have to keep that in mind as well. But again, it's quite effective, and I got some useful data out of it. So that's all I had to say. I'm open for any questions you have. Sorry, say it again? Right, what about it?
Have you tried exploring that one for that?
I have not tried anything with Grafana, no. Just used exclusively Prometheus.
But from my limited experience is that if you actually want to run different queries to export the data, you want to do it directly in Prometheus. And if you want to have a nice dashboard that's visible for everyone.
Grafana, really? Okay.
Grafana has like a nice feature you can like
You
explore.
you basically have your bunch of different graphs that are visible in one row on one screen.
Mm-hmm.
But if you want to add a graph or really explore the data, it's kind of tedious to do it in Grafana.
Okay.
Because you have to define a new dashboard.
You can't really do it interactively, is what you're saying.
In a way you can, but it's not really meant for that, as I understand it.
And you know what, like I use Grafana. It's just like new versions. They have like cool like features. You can like build metrics automatically. You don't have to write them yourself. You can like just click and click.
Okay.
Just do click apps to like make metrics, which is very nice. I have a question also. How do you store the data for the Prometheus? Do you just have like some Prometheus running that just like collects and everything, or do you have multiple Prometheuses? Do it like because the metrics you lose them, right? If only the Prometheus stores them. right? So is that just out there, or do you have backend?
So I'm just running just a single Prometheus instance on my PC, and I'm just importing the open metrics when I need them. So if I wanted to set up some dashboards that were available all the time, or had this data available all the time, then I'd have to do something a bit more intelligently. But right now, I just export from Test Clutch, import it into Prometheus, and then I'm okay. Of course, I had to set the lifetime of the data so it wouldn't garbage collect after whatever 90 days or something. I forget what the default is. But otherwise, yeah, just use that.
Regarding the window timing that you mentioned, how is it like shows exactly the timestamp? For example, the commits, the matrix also comes with the timestamp, or?
So, yeah, as part of Test Clutch, it does a git clone of the curl repository, and it lists all the commits and gets the timestamps based on the commit timestamp right within Git. So that's one of the part of the pipeline that just pulls in from there. So then it has available all that data to generate those graphs and the tables there.
Can you please go one slide back?
Sure.
So, I'm wondering, when you say that it can become misleading, can you give an example of what sort of traps one can fall into if you try to, hide the gaps just for neat output?
Right. Well, again, it depends on the query that you're developing. So, in this case, we have whatever 150 or something CI jobs that will generate data, and if one of those jobs, is failing continuously or something, or one of the jobs is failing half the time or something, and then you look at a window that is beyond that failing time, then it's just going to sort of ignore the fact that it's gone. The other thing is these jobs that we're running are not run on a regular interval. They're just run haphazardly whenever a new commit is checked in. So you can get two completely separate test outputs a minute apart, and then nothing for the entire weekend because Daniel's on vacation and everyone else is sleeping in, and so it's just so you have to choose a value that will sort of hide that missing data, because it's just too distracting looking at graphs and having all these gaps in there. So it's just something to keep in mind. It's just the way it works, and
it's all effects from that first one. It's really meant for continuous gauges.
Yeah.
These really are on that.
Right,
Right,
because if
exactly.
continuously, then you would know when there's a genuine gap and when it's
Right. If you got that test, if you got your job, serving or doing something continuously, and if that crashes, then you want to see that. And
Yeah,
that's
exactly.
really what it's designed for. Yeah.
So are you able to discover problems from these graphs and data, or do you use it only for investigations when you find out through other means?
Well, basically, this is a bit of an experiment just to see if I could get useful data out of it. So I built the OpenMetrics exporter, and then I wanted to see, is this worthwhile doing something more? Is it worth spending some time, maybe getting some dashboards going or something? And I found that definitely you can get some useful data here. I don't know if Prometheus is the best way of analyzing this. It's worked reasonably well. Again, you've got some caveats here. But it's, I think as a proof of concept, it's shown itself.
Looks very impressive.
Yeah. I mean, maybe there is a better tool, but at least one advantage of this is that a lot of people are using it. So you can find out things, you can get help, you can...
Yeah. And again, OpenMetrics is somewhat of a standard, so I should be able to pull it into another tool and use that as well.
Exactly.
Yeah.
I wonder, it's funny, I was thinking of performance regression tests, like, people sling code in, and how slow does curl get because of this, yeah? And you have enough metrics coming out of the average test time. I wonder if that's a good proxy to tell us if we have a regression in performance.
Yeah, I don't know. Is this the...
It is perhaps in a sort of
Blocky.
roundabout way to do it, but yeah, it could be.
Yeah.
The problem is that someone is introducing noise by optimizing the test.
Exactly.
Well,
So
right.
you don't know why. But I'm sort of with that too. I think isn't the problem just to identify which kind of
ways to illustrate this that are good, and
Yeah.
we want to have that, because as we've shown several examples, when you kind of detect problems and you can see it in the graph, that would be an awesome graph, right, to have in the dashboard, because then we could just monitor that things look good.
Yeah.
Yeah, the direction is
Right.
what it should be, and one of these days it'll go up or down, and we notice it. But the problem is figuring out exactly which of these graphs should we show.
Exactly.
But that's what you're doing now. I think.
Mhm.
Yeah, I guess you would define a specific set of tests to run that wouldn't change.
Yeah.
So the individual test runtimes is available in the database. So I don't think I'm exporting it. I'd have to double check. I don't think I'm exporting it right now.
Yeah, the total runtime.
The total runtime, but again,
Average test time.
if someone breaks the HTTPS tests and not HTTP, and they're all of a sudden 5 times as long, you'd see a little bit of an increase in the total time. But if you break it down by like protocol being tested or just individual tests, then you'd see big jumps in some of them. So, but again, if we know that this is going to happen, we can create the perfect graph to show it later when it does. Otherwise,
You first have to explore the data like this to figure out what's useful, what's not,
right.
and so on.
Mm-hmm.
I wonder if it's worth adding a tag in the test to say this is stable, use this for performance, metric. Or, I don't know if you can trace back a test that you would want to group up in a certain way here.
Mm-hmm.
I think performance should be done separately.
Yeah, this
Because
is
it's
a cheap way to do performance. I agree with you. I think, but I think it's better than nothing. Like at the moment, I kind of feel we're blind.
Yeah, it might be better than nothing, but I think you can find more test problems with this, more than performance problems.
Yeah.
And our distributed test suite might find a performance problem quicker.
I did this scorecard Python script, which tests some performance related, like download speed, upload speed, request per seconds on HTTP and HTTPS basically. Just to measure like, have we improved something or not, when I was starting to refactor several things. And we used that, that was a talk from last year, I used that also I found then that our memory consumption had increased in some versions. The performance was still okay, but the memory consumption very much increased, and that we could address that. So, but you can also only identify this if you have a fixed test set, which you can repeat, and the environment which is more or less stable. Otherwise, I mean, for example, like when we have a dependency on some MSys VC package thingy that changes constantly, you can't really tell anything. If your performance goes up and down, it could be the external things you load in, or it could be a changing curl. And the new common test cases, also we expand them, we change them. So I think you really need a set of performance tests of the things you want to measure, and then repeat that over time.
Yeah, and honest.
On the same hardware as well.
Yeah, this is the thing on a stable server.
Doing things.
I mean, what I do is like, I'm not if I measure with the current version of this, like download speed or request per second, I do not compare to the number from last year. I run the earlier versions also on today. Right.
Yeah.
Because it might be you got a Linux kernel or Debian update that improved something or this, so the performance is
There's a
tricky.
lot of factors.
Yeah.
So ideally you would have a set of tests and you would run the different curl versions or different tags or whatever, one after the other in the same setup, and then compare.
What if you could use something like CacheGrin to get like machine cycles, or to sort of normalize it? So even if you're running a really slow machine, number of cycles should be basically the same.
Okay.
But that would really slow things down, and don't know if that would solve it entirely.
because of that too.
Yeah.
Yeah, and you have the network effect, right? It's not like you don't have a calculation on it. Also waiting for data, so if it's slow, the answer from the server is slower, and you have more cycles on the waiting maybe, or
That's
whatever.
true. That's
Yeah,
true.
or some mutex internally
So
is
you're not
spinning or
actually
something.
pushing the same thing, right? Because
Yeah.
it runs slower.
It's tricky.
Yeah.
You can run it 1,000 times and average them. Yes.
Yeah.
To even that out.
Yeah.
Yeah.
One thing you could get out of this right away is the thing Stefan mentioned about the GitHub being more jittery in the afternoon. You probably see that.
That's a good point. That would be pretty easy to show. Yeah, yeah. Like show by test, like when the test data comes in, when 2-hour blocks or something. And
Yeah, exactly.
You
compare.
can see maybe in the network you can see like a gauge with like now is a good time to put
Recommended time.
I'm not sure how easy it is to get the jitteriness out of it. I mean, on the graph you see it immediately.
Yeah.
So the raw test data, do you keep them all, or are they still deleted after some time?
So at the moment, I'm not deleting any data, but every few months I have to buy a bigger disk for my VPS. So at some point I'm going to want to stop to do that and just clear the data. But I have about a year's worth right now. So yeah, we'll see.
So how fast is it growing?
The database is roughly 32 gigabytes or something like that at the moment. So it's just using SQLite right now. But yeah, open metrics, when I expand that, it just blows it way up.
Right.
Yeah, before Prometheus brings it back down to a reasonable size again. Yeah.
The open metrics are, it's a text format? Or?
Right, right. Yeah, I had a little slide on it.
Format with potentially a lot of comments in it,
Mhm.
Yeah.
which is good for understanding what
Choose
is
Yeah. It compresses really well.
Yeah, I could imagine.
All right, any more questions?
Okay, thank you very much.